Today we're going to talk about how to make a chart to help you find or see the pattern. We are going to find the pattern rule, and then we're actually going to use the pattern rule and apply it to find out what the, let's say, 20th or 250th item in the chart might be. That way we don't have to build everything. So we're going to start with an easy one, comparing the number of wheels on the bicycle to the number of bicycles. So I want to know how many wheels I have for any given number of bicycles, or if we think about it this way, we need X is going to equal the number of wheels. Pause the video for a couple of seconds and see if you can figure out what the chart would look like. Here's the chart. If you didn't come up with this chart, don't worry, we're going to do some more examples. If we had one bicycle, oh, I'm writing in white, that's better. One bicycle, how many wheels would we have? Take a second to think about that. We should have 2 wheels. So if I have 2 bicycles, then I should have 4 wheels. Now I can keep on going and figure out some more. But let's say that I wanted to know what the number 10, the 10th bicycle, how many wheels it would have. Or let's say I wanted to know what the 200th bicycle, how many wheels it would have. So then that's where a pattern rule comes in handy. Now we've made the chart. Now we're going to talk about the pattern rule. This part's pretty easy. I think everyone can see that the pattern there is going to be +2, +2, all the way down. Now if we wanted to get to the 10th one, we could go +2, +2, +2 till we get there. But if you remember, we talked about there's an easier way to do that. So instead of doing it that way, we want to look at finding the pattern from here to here, from this number to this number, from this number to this number. Now remember, it can be a plus, it can be a subtraction, multiplication, division, or it can be a combination of 2 of them. So to get from this number here to this number here, we could be talking about +5 times 2 or anything like that. In this case, I want you to pause the video and see if you can figure out what the pattern is. Let's start with the first one. To get from the number 1 to 2, there's a couple of things we could be doing. Could be +1. So I'm going to try that out on my second one. 2 to 4. 2 plus 1, that's what I think it might be, equals, now my question is, does it equal this number here? And in this case, it doesn't equal 4. Doesn't equal. So we know that 2 plus 1 does equal 3. That can't be my pattern, but I needed to try it. So I know it's not +1. That means I need to try something else. So what else could be happening to get from the number 1 to 2? Well, it could be timesing by 2. Let's give that a try. We know that 1 times 2 is going to equal 2. That's the right number. So now we're going to apply it to the next one and see if it works there. So let's try times 2 on this one. We've got 2 times 2 equals 4. And that is the number we're looking for. Now we're going to try it on the last one and see if it works there. 3 times 2 equals 6. It is the right one, so we know that our pattern rule is going to be times 2. So we can say X times 2 equals the number of wheels. So let's try that if X was 10. We would just substitute that in. 10 times 2 equals the number of wheels. So that would go there. Now let's try it for 200. 200 is our X. Times 2 equals 400. So there would be 400 wheels on 200 bicycles. Because we figured out what the pattern rule is, we don't have to go and draw 200 bicycles or find 200 bicycles and count every single wheel on every single bicycle. We can just say if there was 200, apply our pattern rule, then there would be 400. It's much easier. Okay, here's that hexagons and triangles one that we did in class. I just wanted to review it. So remember, we have figure number 1, 2, 3, and we know that we've got 1 hexagon in the first one, 2 hexagons in the second one, and then we would have 3 in the third if we did the third figure here. So this one is figure 1. That should say figure. It's my messy writing again. And then this one would be figure 3, but I'm not going to try and draw that on here. So the number of triangles, we need to count them up for figure 1. 1, 2, 3, 4, 5, 6. And on figure 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on figure 3, there were 14. And there are 2 different pattern rules we can find here. First, we can find out if we know what the figure number is, how many hexagons would there be? And remember, we figured out that that could be either plus 0 or times 1. It would give us the same answer. So let's apply it here and see if it works. 2 plus 0 equals 2. 2 times 1 equals 2. We apply it here and it works just fine. So then if we wanted to find out what the, let's say, 3,702nd, how many hexagons there would be in the 3,702nd figure, we would just plus 0 or times by 1 and find out that our answer would be just like that. The other one was a little bit trickier. We were trying to figure out what the pattern rule is to get from here to here, here to here, here to here, and then for our mystery number, let's say 25 to here. How do we find out how many triangles there are if we had 25 hexagons, if we were figuring out figure number 25 without having to build figure number 4, figure number 5, figure number 6, all the way up to 25. So we don't have enough triangles in our classroom to do the building of this. So we need to figure out how many triangles there's going to be for figure number 25. That means we need a pattern rule. You probably don't remember this pattern rule, so I want you to pause the video and see if you can figure it out. I'll give you a hint. This one involves 2 different steps. There's a plus and a multiplication, or an addition and a multiplication. Okay, hopefully you figured it out, but I'm just going to go ahead and tell you. In this case, we are doing x times 4 plus 2. So let's substitute that 25 in and see what we get. Under the x is the 25 times 4 plus 2 equals 25 times 4 is 100 plus 2 gives us 102. So our answer right here would be 102. Let's try it on the others and see, make sure it works. So let's substitute in the 2. 2 times 4 plus 2 equals, and we're hoping that it equals this because that's going to tell us that we're right. 2 times 4 is 8 plus 2 equals 10. Let's try it on the next one. 3 times 4 plus 2 equals, and we're hoping that it's going to equal this 14 here. Let's try it. 3 times 4 is 12 plus 2 equals 14. So we figured out our pattern rule, and we know that the 102 we came up with is the right answer. Now you try. I want you to make a chart to show the number of cows compared to the number of legs that you would have altogether on your cows. So remember, draw the first 2 to 3 if it helps. Make a chart, find the pattern rule, use the rule to find out how many legs 25 cows would have, how many do 200 have. You can do random numbers, find out how many legs there would be on 3,675 cows. You might want to use a calculator for that one. Go ahead and do this one in your notebook. There should be a page there for the number of cows problem. All right, if you are on this toothpick picture, that means that you've gone through and done the cows and legs problem, and that you've rewatched the video as much as you needed to, so that you feel like you have a pretty good idea, first, of how to make a chart, second, how to find a pattern rule, and third, how to use that pattern rule to find out a mystery number in the chart. So these are figure 1 and figure 2 using toothpicks. I want you to come and see me, and I will give you some toothpicks so that you can build a couple more of the figures in this pattern. Then I want you to make the chart, find the pattern rule, either for the number of toothpicks in a figure, or the number of triangles in a figure, or both if you want a challenge. If you're not sure what you need to be doing, come and ask me. Go ahead and put away your Chromebooks and get started on the toothpick problem.